Welcome to another episode of Terry's Notes, and today I'm going to be looking at question 10 in the May 2016 paper. Okay, so in question 10 they gave you a diagram, not drawn to scale, right? So we have a circle, we have a tangent, which is HK. So HE is a tangent to the circle. FE is also a tangent to the circle, right? And we have straight lines GF and HJ. Now, whenever you are given a circle geometry question, what you should do is try to put in all the angles that you can immediately identify with. Alright, now since HE and FE are tangents to the circle, we know that this length and this length are the same. That is, HE and FE are the same lengths. Right? We also know that if this is 44 degrees, we know that this angle here and this angle here have to be the same, right? So therefore, in the first part of the question where they wanted to find EHF is this angle here, right? So to get EHF, we have a triangle HFE. So therefore, EHF will simply be 180 minus 44 degrees divided by 2. Right? And this will give me, that is 180 minus 44 is 136. And if I divide it by 2, I will get 68 degrees. Alright, so therefore for the first part, EHF, that is 68 degrees, right? So EHF is equal to 68 degrees. Alright, make sure you understand how I get that. It's because we have two tangents to a circle going to a common point. Alright, so therefore this angle here is 68 degrees. It also means that this angle here is also 68 degrees. Now we want to find FGH. Now FGH, where are we? So FGH, we want to find this angle here. Alright? Now there is a rule right, where now FH, this here, FH, this is what we call a chord, right? And we know that this here is a tangent, alright? So if this angle here is 68 degrees, then this angle here is also 68 degrees. So this is 68 degrees, right? And the rule for that is the angle between a tangent to a circle and a chord at the point of contact is equal to the angle in the alternate segment of the circle, right? Now, some of you might remember that rule, so you can put the angle as 68 degrees and state that rule, or you can actually attempt to calculate it, right? And here's how we do that. We have alright, so GF passes through the center of the circle, which means that GF is a diameter of the circle, right? And hold on one second. Right, so if this angle here, this one here, if this is 68 degrees, right, this small angle here has to be 90 minus 68, right? So let me see if I could do all of this on the diagram for you. So this angle here, let's see if I could do that. This angle here is 90 degrees minus 68, which will give me 22 degrees, right? So how did I know to do that? Now, if we look at this here, this line represents a diameter, and the point F is the point where the tangent passes. So therefore, this angle here is 90 degrees. So therefore, this small angle will be 90 minus 68, right, which will give me 22 degrees. All right. Now, OF is a radius, and OH is also a radius, which means that this triangle here is an isosceles triangle. So if this is 22, then this angle here is also 22 degrees. Alright? So we know that this here is 90 degrees, right? Because GF is a diameter of the circle. So therefore, if this angle is 22 and this is 90, then this angle here will be 90 minus 22, right? Which will give me 68. Right? And across here we also have this triangle here. Alright? This is also an isosceles triangle. So if this is 68, it means that this angle is also 68 degrees. Now that working is a little longer, but if you can't remember the rule, you can calculate the angles, right? So like I said, for this one here, all you need to do is to write down 68 degrees, and you just need to remember the rule, right? Which is the angle between a tangent to a circle and a chord at the point of contact is equal to the angle in the alternate segment of the circle, right? That's just the rule. So let's work out JHE. JHE is this big angle here, JHE, right? Okay, so we already know pieces of information here. This will simply be JHE, which will be 68 degrees plus 22, which is 90 degrees, right? And we should have known that that is 90 degrees because JH is a diameter and the point H is where the tangent passes. So therefore that angle JHE must be 90 degrees, right? The other one is JGH. JGH, where are you? JGH, right? That is this angle here, right? Now, if we know that this angle here is 22 degrees, it also means that this angle here is 22 degrees, right? And why is that so? Because there's a rule that says that, right? And the rule in this case is that angles in the same segment are equal, right? So JGH will be 22 degrees, JGE, right, will be 22 plus 68, which will give us 90 degrees. Alright, so we worked out all the angles that they asked us to calculate, right? And I've tried to give explanations as to how we got those angles. Alright, my suggestion is, if you have to do now on the exam paper right now, you have to write on the paper, so you can use your pencil and write in all the angles so that the examiner will see what you're writing, and you should be able to get the marks. Right? Now, the part B of the question, we have two ships S and R on a lake. So we have one ship here and another ship here, and FT is a vertical tower, so this is FT. Right? They said they also told you that the angle of elevation of T from the point S is 40 degrees. That is here. The angle of elevation of the point T from R is 22 degrees. Right? So they've given you the information, and they've also drawn it on the diagram for you. So the first part, they want you to calculate the angle RTS. RTS. Right? RTS is this angle here. Now, we know that if this angle is 40 degrees, we can calculate this angle here. Now, that angle is equal to 180 degrees minus 40 degrees. Alright, and that will give me 140 degrees. So this is 140. 140 degrees. And if we want to get this angle, we know that when we add up the angles inside a triangle, we should get 180. So therefore, RTS is equal to RTS 180 minus, and we must add up 140 plus 22. This will give me 180 minus 162. Right? And that will give me 180 minus 162, and I will get 18 degrees. Right? So the answer for part 1 is 18 degrees. Now we want to calculate the length ST. So that's from here to this point here. Now, if we look at this diagram, we have a right angle triangle, but the only thing we have on this right angle triangle here, which is TFS, is an angle. We have no lengths, so we can't work out anything there. But we have another triangle, which is TSR. Once we have a triangle that is not a right angle triangle, it means that we're going to have to use either the sine rule or the cosine rule to solve our question. So they want ST. So let's see which rule we're going to use here. So we know this angle here is, we just worked out this is 18 degrees. Right? We know this is 140 and this is 22. So we have all the angles within the circle. And they've given us one of the lengths. They've given us SR. Now, if you want to find ST, which is this length here, this length here. Yes. So so you want to find ST. So the easiest thing to do is to use our sine rule. Now, first thing you do is you set up the sine rule. So we say A, we give the general rule first. A over sine A is equal to B over sine B. That's the general sine rule. So now let's apply it to our particular situation. So let me just draw a quick sketch here. Sorry about the crooked lines. Right? See something? So it's TSR. So it's TSR. This is 140. This was 18. SR was, I think, was 150. Yeah. So SR is 150 meters, and this last angle here was 22. So this is 22 degrees. Right. So now let's apply the sine rule to this particular question. We want to find the length st. Alright, so we want to find this length here. This is the length we're trying to find. Alright, so how the sine rule works is that we know that SR is 150, so we should use this angle here. Right, so we say 150 over sine 18 degrees is equal to, we want to find ST, so we should use this length and this angle. It's always the angle and the opposite side. Alright, so it'll be ST over sine 22 degrees. Right, what we do, we cross multiply, so therefore ST multiplied by sine 18 degrees is equal to 150 multiplied by sine 22 degrees. Therefore ST is equal to 150 multiplied by sine 22 degrees over sine 18. Now some students can work this out in a calculator in one go. You can work out the top first and then work out the bottom, doesn't really matter. 150 multiplied by sine 22. I'm going to do it in parts so that you all don't get confused. This will give me 56.19 over sine 18, which is 0.309. Therefore ST is equal to 56.19 divided by 0.309, and that gives me 181.8. 181.8 meters. Right, so that is the length ST. Right, all we did was apply the sine rule to this particular situation. And the last part of the question, they want to find the height of the tower. Right, now we're dealing with the height of the tower here now, so we can let's draw the diagram quickly. Alright, so the height of the tower, this is TFS. TFS. We know it's 40 degrees. Right, we just worked out ST, right? ST was 181.8. Alright, so this is 181.8 meters. And we want to find the length FT. Now, in this question, we have a simple right angle triangle. And we want to get this length. So we have an angle. We know that this is the opposite side, right, in the right angle triangle. The side opposite the right angle is the hypotenuse. So this is your hypotenuse. And therefore this is the adjacent. So if we look at the question, we want to find the opposite, but we have the hypotenuse and we have an angle. Right? So most students, they will try to figure out what rule do we use. And I always tell them, remember SOHCAHTOA. Alright, sine is opposite over hypotenuse, tangent is opposite over adjacent, and cosine is adjacent over hypotenuse. In this question, we have hypotenuse, we want to find the opposite, and we have the angle. So opposite and hypotenuse, that means that we have to use sine. So we set up the rule first. So we say sine theta is equal to opposite over hypotenuse. So therefore sine 40 degrees is equal to opposite, which is what we want to find, which is ft, over hypotenuse, which is 181.8. 1.8. Put this over 1 and we cross multiply. So therefore ft is equal to 181.8 multiplied by sine 40 degrees. Therefore ft is equal to 181.8 multiplied by sine 40. We end up with 116.9 meters. Okay, so we worked out the trigonometric question using the sine rule and our right angle trigonometric ratios. All right, okay.